In the name of Allah, the Compassionate and the Merciful. Hello guys, in this video I'm going to show you how can we optimization problem with Excel. As you see, I have three sheets which all of them talks about Truss optimization, but three different examples. As you see at the top, I have an objective function. The first one is indicated about linear energy function. The second one is the weight of structures, truss structures, and the third one is about the equilibrium equation of the truss. And in here we have output analysis data which are calculated by Excel solver optimization problems, and these ones are our answer of analysis. And so we defined constraint, for example, for area of section 1, area of section 2, the minimum and maximum constraint, and delta 5 until delta 12 is the displacement of this truss. As you see in this example, the structure has 12 degree of freedom, but just 8 degree of freedom is really. So actually for solving and getting the solution, we have 8 degree of freedom for solving. So as you see, the length and height of this truss structures is shown, and you can define just the blue ones for changing your model, for example minimum and maximum, but the green one is calculated by computer optimization. And member of structures, coordinates, and area of structure, module of elasticity, stress in yield position, actual force, available stress, all over stress, and if it shows the ratio of if it is executed from all over the stress. And in this position you can define your node force. For example, in node 2 and 4 in direction y, we have a -5 force. It is free unit, you can change it in your unit position. And for defining each element's stiffness as a local stiffness, and here, and for each of these actually 10 elements, we have 10 local stiffness matrix. And when we combine it and assemble it, all these matrices, we have this matrix. And then for just 8 degree of freedom, which is going to be solved by equilibrium equation situations by Excel solver, so we have these positions, and applying load to this vector. And after solving the equations, displacements goes to up here, and then actual forces is calculated. So let's see the constraint and situation which is solved by Excel solver. So I active the Excel solver in data tab. So let's see. So as you see, I minimize the weight my objective function is the weight, and for example, C11. Let's see what is the C11. Yes, C11 here. For example, I want just this area A6 is between must be between 5 and 30, for example. I use for all these areas this constraint, and for example, for this constraint F130, let's see what it is. Yeah, as you see, I defined this constraint for solving my linear equilibrium equations, and constraint for checking that the available stress must be less than allowable stress, this one and this one. So the available stress must be less than or equal to allowable stress. So if it is the same, so the stress ratio is equals to 1. So it is the critical positions of this structure. So I use the select as a solving method is GRG nonlinear. So if I put the solve, then after analyzing, this area is filled. So and it shows that the optimum area of these structures is 8 to 810 for all 10 members areas, and all displacement is calculated. And in this method, which is solved with Excel solver, you can easily define your model as a complex model with the linear or nonlinear conditions or constraint for very complex modeling of more complex structures. And let's see the second truss. As you see, it is a different truss, as a prot truss, I think, and yeah, in the graph rhythm number 9 is realist, and just node 2 is not realist. And let's see, objective function, or I'd better say target function, is this one is defined. So in this example, height of the truss is going to be calculated by Excel solver. For our optimization problem, I used the minimum and maximum for constraint situations in Excel solver, and area of all members, and displacement of all members. So, and length of this structure is defined. So you can change it, just the blue fonts, and the green fonts is going to be calculated by Excel solver. And all members, coordinates, and moduli of elasticity is shown, and you can define just the blue ones. Here is just the blue ones, blue points, and local stiffness matrix is shown, and then all assembled in here, and then equilibrium equations solved by Excel solver, and with this constraint. And after analyzing and getting the displacement of each node in x and y direction, displacement goes here, and then actual force is calculated. So and we have a reaction here, and if the available stress available stress must be less than or equal to allowable stress. So as you see, if the this ratio is compared to each other, so we have a stress ratio is equals to 1, so we have an critical positions. And if you change it this constraint, we have a different answers for our problems, and we must work on minimum and maximum constraints for getting the best answers for our modeling. And after analyzing, displacement of this truss is shown. You can change your scale for better showing the analysis. So let's see the third example of truss, and as you see, it is the same as last structures, but degree of freedom number 9 is unrealistic, and the structure is the same, but just the reactions of the structures is increased to 4 degree, and actually we have this degree of freedoms in here. And as you see, the height of the structures, the truss structure, and area of each element, we have 13 elements, is going to be calculated by Excel solver, and we have defined the minimum and maximum constraint for this example, and it is same as the last example, but just this constraint is different, and it is checked available and allowable stress here, and all the same. As you see, constraint of this example is going to be calculated in here. And if we check the solver for this example, as you see, all constraint is here. We minimize the target function here. You wanna minimize the weight of truss structures, and then finally going to be calculate this object, these variables, the green variables, such as height of structures, area of the truss, and displacement of the truss structures. And we use the solving method as a GRG nonlinear. So it is shown that it's very simple for modeling very complex of structures. So in these examples I use the truss. You can use it for any kind of structures you like in 2D or 3D modeling, with different conditions, with different situations you like. So thanks a lot, guys. I'd be glad to know your opinion about my analysis method in Excel solver. So bye.